Okay, this video is to help you get started on the sample space slides. Okay, in this lesson, we're going to look at compound probability. Okay, you guys have done simple probability with just one event. Compound is working with two or more events. Okay, first of all, the definition of probability of a single event is the number of favorable outcomes over the number of total outcomes. Okay, before we get into the specifics, let's look at a few definitions. Okay, we need to know what a complement is. The complement of an event is everything but the event. Like the complement of event A is not A. Okay, so for example, the probability of choosing hearts in a deck of cards would be 13 hearts over 52 total cards. Okay, that reduces to 1/4. Okay, the complement would be the probability of not choosing hearts. Okay, that would be 3/4. The trick is the probabilities will always add up to 1 or 100%. 1/4 plus 3/4 is equal to 1. Okay, another example, probability of spinning 4. Okay, on this spinner, there's one favorable outcome, the 4, and there's 10 total outcomes. So the probability of spinning 4 would be 1 out of 10. The probability of not spinning 4 would be the other 9/10, 9 out of 10. Okay, so they add up to 1 or 100%. Okay, there's also something called mutually exclusive events. Mutually exclusive. They can't happen at the same time. Okay, it's just events that cannot happen at the same time. So an example, you can't spin purple and green at the same time on the spinner. Okay, you can't roll a 2 and a 6 at the same time when you roll a dice. Okay, mutually exclusive. Okay, let's look at sample spaces. Okay, now compound probability is the probability of two or more events occurring. Okay, you've done single events last year. Okay, this is compound, two or more events. Okay, one way, we'll do another way later, one way to determine the probability of a compound event is to create a model. Okay, we're going to do tree diagrams, tables. A list could be considered, a table, you could get a list from a table. Okay, once you create a model, okay, we're going to come up with a sample space. A sample space is an organized list of all the possible outcomes of the event. Okay, I think when we do some examples, you'll see what I mean. Okay, let's do a tree diagram first. Okay, Deidre has white socks and black socks. She also has a pair of Nike shoes, Crocs, and Converse shoes. Create a tree diagram to display the possible outcomes if she wears one type of socks and one type of shoe. Okay, so we kind of think of a tree. We're going to branch off. The first outcome, is the socks. So I'm going to type in black socks and white socks. She's going to wear socks. And she's also going to wear shoes. So we're going to branch off the other event, which is shoes, from the socks. Okay, so if she wore black socks, she could wear the black socks with Nikes. Okay, Nikes. She could wear black socks with Crocs, or she could wear black socks with Converse. Okay, we could do the same thing with white socks. She could wear white socks with Nikes, white socks with Crocs, white socks with Converse. Okay, we're just branching off the shoe outcomes or possibilities from the sock possibilities. And now if you kind of look straight across, you could look at it as black socks with Nike. Okay, so we wrote that down in our sample space. Black socks with Crocs, black socks with Converse, white socks with Nikes, white socks with Crocs, white socks with Converse. So when we write those out in a list like that, okay, that would be considered a sample space because that's all of the different possibilities. Okay, all the things that she can wear, all the combinations. Okay, so now we can use the sample space to figure out some probabilities. Okay, probability that she's going to wear white socks. Okay, let's look at the sample space. How many of these outcomes are favorable? Okay, there's 3 that have white socks, right? And there's 6 total. So that would be a probability of 3 out of 6. Okay, now that reduces to 1/2. Okay, probability of white socks and Converse. Okay, look at all the different times when we can find that favorable outcome of white socks and Converse. Okay, so it only happens once. So 1 out of 6. Okay, any socks and Crocs. Okay, so that's telling us it could be black socks with them or white socks with them. Okay, so there's 2 favorable outcomes and there's 6 total. So 2/6. Okay, that reduces to 1/3. A probability of black socks, Nike, or Converse. Okay, so black socks and either Nike or Converse. Okay, so black socks, Nike would work. Black socks, Converse would work. Those are the only 2 that would work. Okay, black socks with Nike, black socks with Converse. So there's 2 favorable outcomes, 6 altogether. Okay, so that's also 2/6, okay, which also reduces to 1/3. Okay, so that's called a tree diagram. Let's do one more problem. Okay, Liam rolls 2 number cubes, create a model to display all the outcomes. Okay, so 2 cubes, okay, 2 dice. Okay, we could have a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6. I should have made this clear. This down the column, that's just the first dice. Along the top here, that's the second dice. Okay, and he's doing both at the same time. Okay, so looking at the second row here, he could roll a 2, then a 1, a 2, then a 2, a 2, then a 3, 2, then a 4, first a 2, then a 5, 2, and a 6. You get the idea? A 3 with a 1, a 3 with a 2, a 3 and a 3, a 3 and a 4, a 3 and a 5, and a 3 and a 6. I'll just type these in quickly here. I'll try to. 4 and a 1, 4 and a 2, 4 with the 3, 4 with the 4, 4 with the 5, 4 with the 6. 5 with all of these, a 5 with the 1, a 5 with the 2, a 5 with the 3, a 5 with the 4, a 5 with the 5, and a 5 with the 6. And then 6 for the first dice, a 6 with the 1, 6 with the 2, and with the 3, and with the 4, and with the 5, and with the 6. Okay, so this is all the different possibilities of rolling 2 dice. Okay, so we can use that to answer some questions about these 2 dice rolled together. So like the probability of both being even. So what I'm going to do is get an image up. Okay, if I want the probability of both being even, I want to think about my favorable outcomes. Okay, I want to think about all of the ones where both are even. Okay, none in the first column would work. See, the second number is always 1. Okay, 1's odd. But in the second column, we have a 2 and a 2, and a 4 and a 2, and a 6 and a 2. And then nothing works in the third column because the second numbers are always 3s. Okay, but in the fourth column, we have a 2 and a 4, they're both even. A 4 and a 4, they're both even. 6 and a 4, they're both even. Okay, nothing works in the fifth column, but a 2 and a 6 and a 4 and a 6 and a 6 and a 6 work. Okay, so that's the favorable outcome. Favorable outcomes. Let's see, 3, 4, 5, 6, 7, 8, 9. There's 9 out of 24. Okay, 9 out of 24. Let's see here. I'm sorry, 9 out of 36. There's 36 total outcomes. Sorry about that. So there's 6 rows of 6. There's 6 rows of 6. So there's 36 favorable outcomes. Excuse me. Okay, so if you reduce 9 out of 36, it reduces to 1 out of 4. Let's do one more together. I'll let you do the last two. Okay, the probability of even and for the first one, and a number less than 5 for the second one. Okay, probability of even, and then a number less than 5. Okay, we've got to think about this. Okay, I'm just going to start with the first column. Even, the first even I see for the first number is 2, and then 1 is less than 5, so that works. Okay, 4 is even, and 1 is less than 5, so that works. 6 is even, and 1 is less than 5. Okay, second column. 2 is even, and the second 2 is less than 5. Okay, same with 4, 2, and 6, 2. Okay, fourth column. Okay, let's see. 2 is even, 4 is less than 5. 4 is even, 4 is less than 5. 6 is even, 4 is less than 5. Okay, now look at this last column. The second number has to be less than 5, so none of those work. None of those work at all. Okay, so let's see, it looks like we're going to have 9 favorable outcomes again, just like the other one. So 9 out of 36, and that reduces to 1/4. Try the last two on your own. I don't want this video to be really long, and it's getting too long. Try them first and see what you get, and tell me if you have any questions. You should end up with 3 favorable outcomes over 36, and that reduces to 1/12. And you're going to get the same answer for the last one. 3 favorable out of 36 total, and that reduces to 1/12. Okay, let me know if you have questions on those 2 problems or on anything else. Okay, and I'll help you.